There's an interesting GMAT data sufficiency question. I'll classify this question as a 700 level question. It's from the topic probability, but at the core of this question, the heart of this question is actually a number properties question. It's a 700 level question, not because it is testing some very intense concept, but primarily because there are quite a few places where we can trip and fall and therefore end up with an incorrect answer. Let's get started. Set A contains distinct integers. What does set A right now contain? It contains 2, 4, 6, minus 8, and it's got two other numbers, x and y. If these are distinct integers, both x and y will be integers and x will not be equal to y. That's information we can deduce right now. When two numbers from the set are selected and multiplied, what is the probability that the product is less than 0? Let's look at the statements in a while. Let's even answer the customary 2 or 3 questions about sufficiency and answers in a while. Let's try and see what is to be found out. We need to find out that the probability of the product of two numbers selected from the set is less than 0. First question, when will the product of two numbers be negative? If it is less than 0, it is negative. The product of two numbers will be negative when one of those numbers is positive and the other number is negative. So the product of two numbers is positive when one is positive and the other is negative. So what does this actually translate to? The set already comprises 3 positive numbers, 1 negative number, and it comprises an x and a y. We need to find out how many of these numbers will end up being positive. If we know what x and y are from the information in the statements, and let's say we're able to deduce, let's say both x and y are positive. So how many positive numbers we'll end up having? We'll end up having 5 positive and we'll have 1 negative number. The product is going to be negative when we pick 1 positive and 1 negative number. How many ways can we select a positive number from 5 positive numbers? We can do that in 5 ways. How many ways can we select a negative number from one of the only negative number available? We can do it in only one way. So the number of ways in which the product could be negative is 5 in that instance, provided x and y are positive. It will be a different answer probably when x and y are negative. So gist of what we have to find out is how many of these numbers in set A are positive and how many of these numbers are negative. Keep in mind, in some of the possibilities, the statements demand, one of these numbers could even be a 0. So don't look at only positive, negative. X or y or even both could be 0. So let's keep that perspective in mind. So what does that essentially mean, or the possible values that x and y can take? Right now we have in set A 3 positive and 1 negative, 2, 4, 6 the positive numbers, minus 8 the negative numbers, and then we have x and y. So let's list down the possibilities that x and y can take. Both x and y can be positive. In that case, if both are positive, the set already has 3 positive, it will end up having 5 positive and it will have 1 negative number. So that's what it's going to have. I'm not going to list down for all of these things. I'm just giving you an idea for 1 or 2 of these things. Both of these numbers could be negative. We already have 3 positive and 1 negative. We are not adding any more positive numbers. So in that scenario, we'll end up with 3 positive and 3 negative numbers. We could have one of these numbers as positive and the other number as negative. So you'll have a 4 plus 2 combination in that case. Both these numbers are 0. So you'll have 3 positive, 1 negative and 2 zeros. One of these numbers could be a 0 and the other number is a positive. So you'll end up having 4 positive, 1 0, 1 negative. One of these two numbers is 0 and the other number is negative. So you'll have 3 positive, 2 negatives and 1 0. So essentially we have 6 possibilities that arise based on what values x and y can take. We're not interested in knowing whether x is a 7 or y is a minus 8. What we're interested in knowing is what are they positive? Are x and y both positive, both negative, 1 0, 1 negative? We need to know their sign. We need to know that is how many of these numbers finally of these 6 end up being positive, how many end up being negative. Let's ask the customary questions. What kind of an answer will this question fetch? This is what is the probability question. So the answer to this question has to be a number. Second question, when is the data sufficient? The operative word is unique. If you get a unique value for the probability, then the data is sufficient. What information do we have from the question stem? 2 things. 1, the set contains 6 numbers, of which we know values of 4. 3 of them are positive, 1 is negative, and we have 2 variables given to us. We know information about the variables, that these variables are integers and they are distinct integers. So these are the information that we have from the question stem. Now let's delve into statement 1. Statement 1 tells us that x into y is not equal to 0. This is set A for our reference. The product of x and y is not 0. Then neither of these numbers can be 0. That's the inference. Neither x nor y is 0. So what are all the possibilities that we have for x and y? Both x and y could be positive. In that case, the set is going to contain 5 positive and 1 negative number. We already have 3 positive. Both of them have become positive. So we'll have a total of 5 positive. Possibility 2, both of these numbers could be negative. We already have 3 positive. 1 negative. We're adding 2 more negative numbers, so set will comprise 3 positive and 3 negative numbers. Lastly, one of these numbers could be positive and the other number is negative. In that case, we have 3 positive, add 1 more positive. We'll have 4 positive. We have 1 negative, add 2 more negatives. That's going to add 1 more negative. It's going to make it total of 2 negatives. So these are all the possibilities that we have given the information that neither x nor y is 0. Will we get a unique answer with this? We won't. Just let's compute the numerator of the probability. The probability comprises 2 parts, one in the denominator and one in the numerator. The denominator is going to be selecting 2 numbers out of 6. That's common for all these 3 possibilities. In the first case, the probability that the product is negative, we need 1 positive and 1 negative number. How many ways can I select a positive number? I can do it in 5 ways. In how many ways can I select a negative number? That can be done in 1 way. So 5 into 1 equals 5. Let's look at the second possibility. How many ways can we select a positive number? That can be done in 3 ways. How many ways can I select a negative number? That can also be done in 3 ways. So we get a different answer. In this case, it is 9. We'll get a different value for the third possibility. So we will not have a unique probability based on the information given in statement 1. So statement 1 is not giving us conclusively how many positive and how many negative numbers exist in the set. 1 alone is not sufficient. So let's rule out choices A and D. We are down to B, C or E. Move on to statement 2. Evaluate that to determine whether it is B or if you have to combine and determine whether it is C or E. Let's move on to statement 2. Which is modulus of x equals modulus of y. These are all the elements of set A. What do we mean by modulus of x equals modulus of y? Modulus of x equals modulus of y. The magnitude of both these numbers is the same. So magnitude of, let's say, a minus 4 will be equal to modulus of 4. Or it could be modulus of 4 could be equal to modulus of 4. So if the modulus of x equals modulus of y, broadly there are 2 possibilities that exist. That x equals y. If x equals y, we'll have a case that both x and y are positive, both x and y are negative, or both could be zeros. But in this question, do we have that possibility 1 existing at all? The question stem explicitly stated that the set A comprises distinct integers. If x equals y, and if let's say both of them are positive, x will be a 4, or let's say x will be a 7, and y will also be a 7. In that case, the set does not contain distinct elements. So x equals y as a possibility is ruled out. The second possibility is x equals minus y, which means they have the same magnitude, but they are of different signs. For example, x could be a 7, y could be a minus 7, or x could be a minus 7 and y could be a 7. So they have the same magnitude, this question mentions it, and they are of opposite signs, so they are distinct. The fact that x is they are distinct, we can rule out the possibility that x equals 0 equals y. If x equals y equals 0, then x will be and y will not be distinct integers. So the 0 possibility is ruled out, both having the same sign ruled out, either both positive or both negative is ruled out. So this distinct as a word that was given in the question stem helped us eliminate possibility 1. That leaves us with the only possibility that x has to be equal to minus y. One of these 2 numbers is positive and the other number is negative. What have we started with? We started with 3 positive and 1 negative. Now we're adding 1 more positive and 1 more negative. The set will end up having 4 positive and 2 negative numbers. And this is the only possibility that is there. Because we know that how many of these numbers are positive and how many of these are negative, we have 4 positive and 2 negative, and a unique product will be obtained. How many ways can we select a number whose product is going to be negative? We'll have to select 1 positive. How many ways can it be done? 4 ways. In how many ways can we select a negative number out of 2 numbers? You can do it in 2 ways. So the numerator of our probability is 4 into 2, which is equal to 8. We have a unique answer. You don't even have to compute this because we are finally solving a data sufficiency question. All that you need to know that we have a unique value for the number of positive and the number of negative numbers in the set. That should suffice. Statement 2 has given us a unique value. So statement 2 alone is sufficient. At the end of evaluating statement 1, we were down to B, C or E. Eliminate C and D. 2 alone is sufficient. Choice B is the correct answer. Now that we are done with this data sufficiency question, let's move and convert this into a problem solving question. Try this yourself. I'm basically plugging in the information that we obtained from statement 2. Statement 2 told us that one of these 2 numbers is positive, the other is negative. So I'm framing a question based on that. Set A comprises 4 distinct positive and 2 distinct negative integers. What you need to compute is what is the probability that the product of 2 numbers selected from set A is less than 0. Post your answers in the comment section of this video. Before you leave, 2 things. Sign up as a trial user at wzko.in/core. It's one of the most comprehensive online GMAT course. Get started with a free topic, statistics and averages. Build momentum to your GMAT preparation. Subsequently, pay up and unlock the remaining topics. Lastly, subscribe to the channel youtube.com/Visaco and spread the word among your friends who are preparing for GMAT. You may also choose to join this channel as a member for a small monthly fee and enjoy member-only perks that come with it and will help you boost your GMAT preparation.